Hello. Today we are going to take one analysis of ball impact analysis on a plate. For that we have to create first plate, then ball. We have to give the material properties to respective plate and ball. Here ball we are considering the as a resin material, made up of resin material. Okay. And first of all create the plate. I am giving its coordinates. Plate is considered of 100 by 100 size. Then its first coordinate I am taking as 0 0. First coordinates of first node, the second of 100 0, third of 100 100, and fourth is 0 100. If you fit, then you can see these 4 nodes. Then by using F6, create one chord element. This is wireframe. Convert into solid and again remesh it. Select a chord size. I am taking 5, means on each edge we are getting the 20 elements. Yeah, this is first component I am getting. Here automatic component created, that is auto1. You can rename this by using F2. And I am giving the name as plate. Okay. Then next is we have to create one ball. To create ball we have to find out its center. To find out center, go to effect. In effect select this nodes and select any 3 to 4 nodes, and after that click on create. You will get its center. Now we have to find out the center of that circle, the center of that sphere, not circle. Then suppose radius of that circle is 10 mm, then it is center must be keep 10.5 mm above of this point, or 11 mm. I am taking 11 mm. I am translating this center node by 11 mm in z direction. Here you can see the z direction. I am duplicating this node, duplicates, and z direction, positive z direction in 11 mm. Translate. Here you can see this is center of that circle. I am clearing that one. Okay, now to create circle we have to first create its surface. For this we have to go for geometry in surface, not surface edit, surface. Then there is a fourth option of creating the sphere center and radius. Okay, by using center and radius, select the center and give the radius as 10. We are getting one sphere. Now you can mesh this circle, surface, mesh, and creating this as a solid, or you can keep it as it is shell, no problem. Okay, I'm giving the dimension of 2 or 1. 10 mm diameter is 20 mm dia, or 10 mm radius is 20 mm dia. You can give 2. Trace mesh. Here is mesh is created. No need to find out the free edges, or no need to find out vertical connections. Very simple geometry. Okay, now this again go to plate geometry. Again create one new component for ball. Rename it ball. Okay, now convert this into tria, tetramesh. Select these elements bar attach, create fill volume, or we can say okay. Here this is ball, means go all mesh that elements are going to will go into this ball component. Okay, and keep the that collapse with point to mesh. Mesh is created, and here we can see this is state elements. Sorry, select elements. Okay. After that, of this component, I want to delete this 2D elements of date. No need of that now, but delete. Now we have two components. First is ball, second is plate. Okay. Now we have to create its material and properties. First we will create the material of plate, that is for shell. Then right click on this model browser and go to property. Give the name as plate. Now edit it. By default it is taken card images, section shell, here form 16, share factor 0.833, NIB 5. Thickness we have to define 2 mm. This is for plate. Second for ball. Ball is of solid. Then we have to select the card image section solid. For tet we have to select the shell EL form of 1.81, that is 10. Again create material. First for plate, you can give the same name to identify. Okay. By default card image is matte L1. Give the row, that is density, mass density, that is 7.9 raised to -9 tons per mm cube. This is 210 000. Poisson's ratio is 0.3. These three values are sufficient to define the material for plate. Again, define the material for ball. We are giving the material for ball as a rigid, means we are defining the ball as a rigid body. For that, select the card image as matte 20. You can see the description of matte 20 in LS9 manual 2. I can give the same properties, no issue of properties here. Then you can apply the constraint by using the CMO. Again, this ball is moving, means there is a no constraint. There is no need to apply any constraint. Okay. Now click on the plate. Click on the plate. Okay. Give the card image as part composite, part, property of plate, and material of plate. Okay, same for ball. Give the card image part, material property of ball, material of ball. Okay, this is done. the next we have to create the we have to fix this plate at the sides, and we have to give the initial velocity to this reset ball. Okay, for that we have to create two load collectors. Here you can create load collector, or by right clicking on this you can create the load collector. For creating the constraint, I am creating the load collector SPC. In SPC now you can see here SPC here generate here. Okay, now go to analysis, constraint on nodes, and doing the by path and fixing all these end nodes in all degree of freedom. In all degree of freedom, it is check. You can see each end nodes are fixed in all degree of freedom. Now apply the initial velocity. Again create one new collector for initial velocity. We can name it as velocity. Apply the initial velocity to this ball. Initial velocity. Now here we have to select the node set ID. Then we have to give the velocity in respective direction. For that, first of all we have to create the node set ID. For that, go to analysis and entity set. Give the name ball, means we are creating the entity set for ball. Card image node, card image. Card image node, and select the nodes of all by the by test. Or by collector, we can go by collector, and we have to select the collector, that is ball. This component or collector and create. Here you can see one node set is created. Now go to velocity, select the initial velocity and select the node set of ball and give the value of velocity in that respective direction. Now if this is z-axis, means it will apply in the negative z direction, and suppose this is I am giving it as 1400. You can find out by using the formula under root 2gh. G is the acceleration due to gravity, and h is the height from where you drop this ball. Okay, or directly you can give the velocity. Suppose one object is impacting on second object with some velocity, then directly you can give the velocity. If it is drop, you can find out the initial velocity by using the formula under root 2gh. Okay, this is done. Now we have to create the contact between the plate and this ball. If you not create contact, then it will not take any contact. It will pass. If you complete the analysis and if you see the in post processing, you will see that this passes this plate. This ball passes this plate, and it will not impact on this plate. Okay, for that we have to create the contact. Okay, contact name is single surface, which is applicable for all. Okay, select the type single surface, card image single surface, and created it. You have defined fs 0.2, fd 0.15. What are this value? You can check in LS Dynam manual number 1. This I am taking 0.2 again, and sorry 1.5 VDC. We see now to check our these are some parameters which define contact. Okay, here you can see the one group is selected and group is created, that is single surface, but still we not define on which elements or on which components we are applying this contact. Okay, generally the single surface contact applies for all, then select directly all. Okay, what's remaining is control card, then go to analysis, control cards. We have to define the control termination and database did plot. Control time step, control termination. Here you can define the control as 100 millisecond. And in database you have to define the database binary D3 plot. Here is you have to define the time required for one plot and give the 10 millisecond. Okay, all done. Okay, now you can export, and before export you can check your model. Go to tools, model checker, ls type. Now error and run. Here you can check the status. All are green and check. There is no red or cross marks. Okay, now I export this .k file for Dyna. Drop down, giving the name for that .k file as drop ball. Okay, export. Okay, this file is exported now in this HM course. Okay, here you can see this file. Okay, now we have to give the path to Dyna. Open Dyna, ls Dyna, ls pp, lstc, ls Dyna manager. Click on this, give the path for that file, number of CPU I'm taking it, and memory of 200 and run. 3 minutes required. Here you can get the value of kinetic energy. 1 of mv square. Find out the mass of ball, find out the initial velocity, and then you can find out the here you can see the normal termination is done. If any error, then it comes as a error. You can identify the error here as well. Yeah, there are 2 plots are created. Take this path and open the hyper. Hyper-V is ready to serve. Now go to the path of the drop down file and select this D3 plot file and open and apply. Here our ball and it will impact and it will reverse. Okay, if you see, you want to see the displacement of this, select the plate, click here for counters, click here displacement, select the part of which you have to select the displacement and click on apply. Here you can see the displacement of this plate. Okay, blue means it is minimum, red means maximum. Maximum is 5.48 e raised to minus 2, means not 0.005 mm displacement, means very less displacement. Okay, you can see the stresses. Select this component, select the maximum, initialize it to the maximum values, apply. There are the stresses. Okay, same way we can see the strain. Back to plastic strain component. Okay, there is no plastic strain, there is only elastic. Okay, in terms all the remaining value you can see. Okay, done with this. You can take the screenshot of this displacement. You can use the button Control Shift and S. Windows Shift and S key to take screenshot, and you can take screenshot like this. Okay. To record the animation, here is the option capture graphics area video. Click on this and give the number or name, anything, and you can recording the animation. This is done with this first analysis. Keep practice it 1 to 3 times. You can get ease on this. Okay, thank you.